Hey guys, we're gonna try to salvage this lesson 5 part 2 video. This is the last part, so part 3. And the first thing we're gonna talk about is frequency, period, and their relationship with each other. So we know that period is the time it takes to complete one cycle. Well, frequency is going to be the number of cycles per a set unit of time. So in conclusion, frequency is going to be the reciprocal of period. So if I have a period of 1/2, my frequency is going to be 2. So on this one, we're going to determine the amplitude, period, and frequency given this equation. So the amplitude, you know where to look for that. And the B is going to be 300 pi, and that T is our variable. So the T can be anything. It can be theta, X, whatever. So I don't really care about that. So to find the period, I'm going to take 2 pi over B, which we know that. So it's going to be 1 over 150. So what that means is it's going to take 150 seconds to complete one cycle. Okay, so the frequency is a reciprocal of that. So what the frequency says is I'm going to have 150 cycles per 1 second or whatever the unit of time is. It didn't give it to us here. So it's just a reciprocal of that. Okay, so go ahead and try this one. Okay, so the amplitude here is 7. The period is 2 pi over 40 pi. That's our B. And so our period is going to be one cycle, is going to take one cycle, like 20 seconds or 20, whatever our unit of time is to complete that one cycle. So the frequency, being the reciprocal of that, is going to have 20 cycles in that one unit of time. Okay, so I want you to go ahead and read through this problem, first of all. So think about a spring. Notice that picture is going up and down and up and down and up and down. And so as we put time on the x-axis, it's going to make an upside down cosine graph, because if I pull it down, it's going to go up and down and up. Okay, so if we were going to go ahead and graph that, it's going to start 16 centimeters below that equilibrium position. So I'm creating this cosine graph that's going to be like a negative cosine graph. So it's going to go down to 16, up to positive 16, down to 16, up to positive 16, and it will go on and on and on forever. Okay, one oscillation, the time it takes for that is going to be our period. So the time period. So we know that that period is going to be 6. So everything is very symmetric. So I know the maximum is going to hit at 3. And then the other points, so like where it hits the x-axis for the first time, that's going to be between 0 and 3, which is going to be like 1.5. And then it's going to hit up to 3, and it's going to come back down on the other side of the x-axis at 4.5. And then it goes all the way down to 6. So notice how symmetric everything is going to be. So our equation is again going to be that negative 16, because that's our amplitude, cosine, and then our B, and we know our period, but we don't know what our B is. And so we're going to take 2 pi over 6. So that B is going to be pi over 3. Okay, so that's our equation for that second part. Now I'm going to determine the position after 1.5 seconds. So I've shown you in the graph, but you can also do this on your calculator. So what we would do is we would put in 1.5 for T and type that in our calculator. And if you're doing it correctly, you should get 0, because look at the graph. Our Y value is 0 at 1.5. So just kind of keep that in mind. I would play around on your calculator. Now we're going to talk about the frequency. So the frequency, if the period is 6, the frequency is going to be 1/6. So there's going to be one cycle per 6 seconds. And you can see on the graph how that works. Okay, so let's do another one and see how that goes. So if you'll notice, it goes down to 3 centimeters. So this is like -3 down here. It's going to go up to +3, and it's going to go back down to -3. So let's watch that. I also know that it's going to take 10 seconds to get from point A to point B. And so here is our equation. So our amplitude is -3. Again, it's going to be a cosine. So almost every time you have this situation, it's always going to be cosine. So if our period is 10, then the formula is 2 pi over b. So we can figure out that b is pi over 5 and put it in there. So that's our equation there. Okay, so this is the last one. There is a problem on your test very similar to this. So just kind of keep that in mind when we're going through this problem. So 1 complete rotation takes 50 seconds. So that is our period. The Ferris wheel has a radius, if you can see that, of 90. And so there's a difference of 100 feet right here. So the radius is 90 and it's shifted up 10. So think about how that would affect our equation, that 10 right there. Okay. So it says write a sinusoidal function for the height above the ground. So I know that my maximum height, so let's think about this, is 190. If my radius is 90 here, this is going to be 190. 90 plus 90 is 180, and then plus 10. And then my minimum height down here is going to be 10. So then this right here, that's going to cut it in half, that is going to be at 100. So that's going to be our K. Okay, so to find B, we're going to take, we know that the period is 50. So we're going to take 2 pi over b equals 50. So B is going to equal pi over 25. So we have our B. We have our A for the amplitude. And this is kind of what it's going to look like. So I'm going to start off on my Ferris wheel. I'm going to go up to the top, and I'm going to go back down again. So notice the shape of this. This is going to be a negative cosine again. So notice that radius right there, that's going to be our amplitude. So our amplitude is 90, so our A is going to be -90. So y equals -90 cosine, and we have our B, pi over 25, x, and then plus 100. And that is going to be our equation. And that's it, guys.